The most distant human-made object is NASA's Voyager 1, now drifting in interstellar space. Launched in 1977, this spacecraft has traveled more than 14 billion kilometers from Earth, far beyond its intended lifespan, yet it still sends back data using technology older than a cassette player. What began as a mission to explore the outer planets has become one of humanity's greatest scientific achievements, and now Voyager has made discoveries that are reshaping our view of the cosmos. The idea began with Gary Flandreau at NASA's Jet Propulsion Laboratory, who noticed that in the late 1970s the four giant planets would align in a rare configuration that happens only once every 176 years. This allowed a spacecraft to slingshot from one world to the next using gravity assists, reducing a 30-year trip to Neptune to just 12 years. NASA seized the chance, launching Voyager 1 and Voyager 2 only 15 days apart. Originally expected to last 4 years, the twin probes are still working more than 4 decades later. Along the way they revealed volcanic activity on Jupiter's moon Io, icy landscapes on Europa, Titan's dense atmosphere, and the frozen mysteries of Uranus and Neptune. Voyager 2 remains the only spacecraft ever to visit those two distant worlds. Each discovery rewrote textbooks, showing the outer solar system as dynamic and alive rather than static and dead. Equipped with computers holding only 69 kilobytes of memory and tape recorders storing data before transmission, these probes survived conditions no one thought possible. Their 23-watt transmitters, barely stronger than a household light bulb, still beam faint signals across billions of miles to massive antennas on Earth. Despite their simplicity, they accomplished feats that continue to astonish. Their most important milestone came at the edge of the solar system. Scientists expected Voyager to cross the heliopause, the boundary where the solar wind meets interstellar space, at around 50 astronomical units. They predicted a sharp increase in cosmic rays and a clear change in magnetic fields. But when Voyager 1 crossed this frontier on August 25, 2012, the data told a stranger story. Plasma density rose as expected, yet the magnetic field barely shifted. Instead of a clean boundary, the transition was blurred, hinting at an overlapping zone where solar and galactic forces mingle. This puzzling result sparked debate. Was the interstellar magnetic field aligned with the solar field? Could the heliopause be a shifting, uneven frontier shaped by solar cycles and galactic pressure? Voyager's findings suggested our neighborhood in the galaxy is far more complex than models predicted. Even more mysterious were the fluctuations Voyager recorded in plasma density. Far from being uniform, interstellar space appeared clumpy, divided into regions of different temperatures and pressures. These plasma clouds may be remnants of ancient supernovae, fragments of violent stellar explosions millions of years old. Each pocket carries a record of our galaxy's turbulent past, etched into the very medium between the stars. Voyager's journey has transformed our understanding of the universe. What began as a 4-year planetary tour has become a 45-year odyssey into the unknown, showing us that the space between stars is alive with structure, history, and unanswered questions. The spacecraft drifts on, carrying with it not just instruments but a golden record, our message to the cosmos, waiting for whoever, or whatever, might one day find it.